In this video, we're going to look at some slightly different probability questions where things change along each of these branches. Okay, and that's because of the wording of the question and what's happening here. So we've kind of had a little look at this in the Star Wars video where the probabilities might change from here to here, but this one is a little bit different, and we've got to read the question very carefully. So we have to look out, and they've even had it in bold for you here, whether we're replacing or not replacing discs in a bag. So here we've got a bag with 10 coloured discs, so you can imagine 10 discs in this bag. 4 are red, I'll just call them 4 R's for the red, and 6 are black. 2, 3, 4, 5, 6. As if it's going to take 2 discs at random from the bag without replacement. So that means what happens if he takes a black disc out, the next time he pulls one out, it's gone. Okay, the black disc is now outside the bag. So you'll notice that as an effect on what's going on in here. But let's go from the top. So we've got 6 black and 4 red. Complete the tree diagram. So this is exactly the same as you've done previously. So we want to count up the number of red discs we've got. So in this case, we've got 1, 2, 3, 4 red discs. So it'll be 4. And we know that there are 10 discs in total. So the chance of taking a red, 4 out of 10. 4 red discs, 10 in total. Which means the probability of taking a black disc should be 6 out of 10. Because remember, each block has to add up to 1. This has to add up to 1. This has to add up to 1. Because they're each individual pull, depending on which route you're going down. So then black disc, just to check. 1, 2, 3, 4, 5, 6. So there are 6. And we could simplify these, but I'm going to keep it out of 10 because the 10 makes a little bit more sense because there's 10 things in the question. Normally we would almost always simplify these fractions, but this is one instance where we might choose not to because it's actually the 10 represents a number of things and therefore it's easier to visualize what's going on. So what will happen is, so let's say we go down the top route, so let's say we're going down this way, we take a red one out first. Normally, if we take a red one out, record its colour and then put it back in, the probabilities for the next bit would be exactly the same. There'd be 4 red and there'd be 6 black. However, that's not the case in this question, because once we take a red disc out, so say we're going down this route, once we take one of those red discs out, so let's imagine that was happening, let's get this red disc, and let's take it out, so we now have the red disc, that red disc goes outside, so let's get rid of it, and we're not replacing it. So if we now look at what's going on in this bag, the number of discs, total discs has changed, there's now 1, 2, 3, 4, 5, 6, 7, 8, there's now 9 discs in total. And the number of red discs is now 3. And the number of black discs is still 6 because I'm not taking a black disc out. So we can still, the probability will still add up to 1, but see how they're different from the original probabilities. So if I take a red disc out first, the bag is then going to look like this, which means the chance of taking another red disc out, there's 3 of them and there's 9 in total. Again, I won't simplify here. And just to double check, well, we know we've not taken any black discs out, so there's still 6 in there. But we have taken 1 out in total, so there's only 9 in total. And we can see the 6 in there and the 9 in total in there. So notice how the probabilities change, and that's all because of this one word, without replacement. If it says with replacement, that means this thing's going back in, so the probabilities reset, and everything will look like this on every single pull. Let's say we go down the other way. So this time let's pull a black disc out first. So we'll put our red disc back in. In fact, I'll make them all red. So we're back to the start. So 4 red, 6 black. This time I'm going to take a black disc out to start with. So I'll take one of these black discs. That's going outside. So I'm removing a black disc so I can rub it out. Then again, we can have a look at what's going on here. So again, we've taken a disc out. So the total number of discs, there are 9 discs in total. Hopefully this is all starting to make sense now. There are still 4 red discs, because if I've taken a black disc out, just black disc to start with, there'll still be the starting number of red. So there's still going to be 4 red. So there's 4 red, but there are 9 in total because I've removed a disc. You can count them up inside that bag. There's 9 there. But I have taken a black out, so that's going to affect how many black discs there are as well as the total number. So if you have a quick look inside the bag again, you'll notice there are 5 blacks, which makes sense because I've taken one of those black discs out. So it's 5 out of 9. But notice that every single pull, 4 out of 10 plus 6 out of 10 is 1, is 10 out of 10 is 1. Every pull, 9 out of 9 has to add up to 1. This one has to add up to 1. We've just got to be very careful of the probabilities, because with this word here, each branch, the probabilities are going to change because I'm removing a disc and I'm not putting it back in. So next time I reach in, there's going to be a different number of discs and therefore different probabilities of pulling out a certain disc. And these are the kind of questions that they like to throw in. And there's going to be another variation we're going to look at, hopefully in this video, if not then the next video, which is it's the principle that's important and should be quite easy to visualize this. It's quite logical, and if it helps to draw a little diagram, especially to start with, then please do that. So there's our tree diagram completed. So we've got chances are red, red, red then black, black then red, or black then black, and they're all the different outcomes that we can possibly have here. Work out the probability that as if we'll take 2 black discs. So the probability of black then black. There's only one way this can happen, and that's down the bottom of this tree diagram. Black then black. Remember, we always multiply along the branches because they're independent events. So it'll be 6 over 10. So the chance of pulling a black one out to start with. And then black one out again. 5 out of 9. You've got your calculators, or you can do top times top, bottom times bottom, and I will simplify here because it's my final answer. So it's a third chance of that happening. Quite a lot of black discs in, so it makes sense for it to be relatively high. Work out the probability that as if we'll take 2 discs of different colours. So the way that 2 discs of different colours can happen, well, either you can take a red then a black out, then you'll have 2 different discs of different colours. That's this one. Red then red is no good because they're the same colour. Black then red is good because that's 2 discs of different colours, so that's another way of getting the outcome he wants. Black then red. And the last option is no good because that's black then black, and that's 2 discs of the same colour. So we want the probability of red then black, so that's down this route. 4/10, then 6/9. So 4 over 10 times 6 over 9, top times top, bottom times bottom. And then black then red is going down this route, so it's 6/10 times 4/9. So that's 24 over 90. And both of these are desirable outcomes. These are both discs of different colours. So therefore, our probability of both discs, or 2 discs of different colours, will be the sum of these 2 things, because they both are the outcome that we want. And therefore the chances are going to go up because there's different ways, different routes to get that desired outcome. So this is 48 over 90, and we should be able to simplify this. To 16 over 30. And I'm going to go down and look at another question now. But remember, you can pause the video, replay it, but this is all about the wording of the question. We have to read the question very carefully. So number 2, I'm going to paste it in here. Hopefully you can read this okay. Make it nice and big. Okay, so again, it's still a probability question, same kind of idea, but this is a slight variation. You could draw a tree diagram for this if you want, but there's a few more options here. So we've got to think of it. We can think of it as a tree diagram, but we can actually do this without drawing the tree diagram if we're just clever in how we think. So 6 counters, B-A-N-A-N-A. 6 counters go into a bag, so you can imagine this happening. B, there's one of them. The A's I'm just going to write in red. There's 3 of them. And the N's I'm going to write in green. There's 2 of them. He takes a counter at random from the bag, he records the letter and replaces it. So this is actually a replacement, so he's putting it back in. So we've got to make sure we read the question carefully. That's a key word here. He then takes a second counter at random and records the letter. So calculates the probability that the first letter will be A and the second letter will be N. So this is a little bit more interesting because we've got 3 different letters that are the same, and the way that the question is phrased is just slightly different. We could draw a tree diagram and have, well, I could pull the first B, an A, or an N, and do it like this. That's effectively what we're doing here, but we can just do it by being a little bit savvy with our approach. So the probability of getting an A and then an N. So if you think about pulling counters out of the bag, the probability of getting an A first, if we look at this bag, the A's are in red, there are 3 A's. So I can pull any of them as a good option. Okay, so that's 3 and there's 6 letters in total, so that's 3 out of 6 chance of getting an A. So we're kind of grouping the A's all together because they're the same outcome. And then to get an N, well, we've taken the A out, we're putting it back in. To get the N, there are 2 N's in total and 6 letters in total. So that's the chance of getting an A first, this one, and then an N second. It has to be in that order. You can't consider N then A because it says the first letter is A and the second letter is N. So top times top, bottom times bottom, and then we will simplify our final answer. So it's a 6th chance of that happening. Probability that both letters will be the same. So we've got to think about how this can happen. So how can I get both letters being the same? Well, either I could pull a B out, then a B out. That would be both letters the same. I can pull an A out, then an A out, both letters the same. Or I can pull an N out, then an N out, and both letters will be the same. There's no other way of it happening. That's the only way this can happen. Now you might think, well, if I pull the B out first, then I'm never going to do this. The probability of this is 0, and it would be if it was non-replacement, because once you've taken the B out, there'd be no way you could get a B again, because if you take the B out, there's no B's left. But because we're replacing it, we can get B then B. So the chance of getting a B is 1 in 6. And it's the same again, because the probabilities will reset when I put the B back in. Probability of getting an A first is 3 out of 6. Put it back in, so it's still going to be 3 out of 6. And the probability of getting an N, there's 2 N's and 6 in total. 2 N's when you put it back in. So that's 4 out of 36. And then all these are ways of getting both letters the same. So we're going to add them up. So that would be 2 B's. But we could also get 2 A's. That's another way. And we could also get 2 N's. So we get 11 out of 36. And that won't simplify. So basically we're building up a tree diagram here of either it's a B, an A, or an N, and then the same thing again. But notice how if we're clever, we can actually think of this like a tree diagram, but not have to draw all of this out. Just think carefully and think about what would happen if we were to draw this out and how this would look. So 2 slightly different examples here. One which is non-replacement. So you just have to read the question, where the probabilities change because you're not putting that disk back in, and that has a knock-on effect on the next time you draw one out. And also one where it's just a bit of a different scenario. We've just got different things, we've got different letters, and we can do it without having to draw a tree diagram if we just think carefully about the different ways of getting the outcomes that we're asked for. That's it.